what we would have saw some of last week is at least identifying what the x-intercepts are, right? And so we could look at this graph and say, okay, well, there's the vertex, right? And there's a y-intercept. We're just like trying to identify all the key features about this graph, right? And then we found the two x-intercepts. Okay. Now this question's asking us to write the equation. Okay. Well, to write the equation, we need to first recognize whether or not this is opening up or down. Well, it's frowning, and so we're going to say it's opening down. Okay. So that must mean, if you guys remember, because I remember we talked about this, we had something like ax squared plus bx plus c. This one's hard to fill out, right? Because I don't know what b and a are. I could, though, recognize that we knew that the y-intercept was c, right? So in reality, I could have something like this. Okay, but not really helpful. Okay, it's not helpful from the standpoint because I just don't know enough stuff for this. I do also know from standard form, though, however, we remember that the a value can be positive or negative. Okay, and that determines whether or not the parabola opens up or down. Okay, well, in this question, if it's opening down, then the a value must be negative. Okay, so that must mean that's as far as we can get with this equation, right? Which is the limitation of it. It's not a great equation from this standpoint, right? It can really only tell us two things: y-intercept and direction of opening. That's pretty much it. Okay. So after I showed you this and we kind of plotted some points and we could plug in inputs, and that's what we spent some of our time doing last week, I then showed you how to factor, right? And by factor, we switch the parabola from looking like this into something that looks like this. It's a number sign, a hashtag. Okay, we switch it to look like that. Okay, it's when it looks like this that we could see, okay, I know x equals something and x equals something. These were my two x-intercepts. This was a little bit more useful, and we spent some time producing these graphs once I had this equation look like this. Okay, so our job here, when I provided a graph and I can clearly see what the x-intercepts are, I put them in there, whatever the numbers are. Okay, and then I just have my equation. Okay, so I'm starting to get sideways here. Okay, so here's what we're going to do. We're going to operate under this model here because this is more useful than this, right? And what you can do is you go and find the two numbers, your x-intercepts, and you put them in where you see those two number signs. Okay, well, let's rewrite this. Y equals, a is going to be 1, okay, but here's the catch. You have to make it negative because it's opening down. All right, let's fill in the rest. X minus, what's the first x-intercept? -4. Let's plug in the other one. X minus, all right, well, I see two negatives here. They're going to cancel, and your final graph, or your equation for this graph, is going to be negative. We don't need to write the 1. x plus 4, x minus 1. That's the equation. Okay? All this stuff up here is a little extra talking going on. Okay, we're going to do the next question just very quickly. Okay? I'm just trying to, this is kind of like a recap from where we were and where we're trying to go. Okay? Does anybody have any questions? Okay, so I just want to, and this is in Mine's Online too, okay? This note, so you guys can look at it, okay? Okay, so when I'm writing things in factored form, this is what it's looking for. Factored form looks like this. Okay? What we need to do is fill in those two number signs, or those hashtags, right? Pound. So we got to figure out, where do those two numbers come from? Well, these are your x-intercepts, right? Where are the x-intercepts on the graph? Where they cross the x-axis. Remember, this is x and this is y. It's where they cross the x-axis. So now rewrite this. Is this parabola opening up or down is your question? Okay. You guys are meeting my dogs here. Okay. It's opening up. Okay, so that must mean A has to be positive. Okay. And so we're going to go, it's positive 1. And we need to fill in the two numbers. Okay. What are the two numbers? Negative 2 and 3. X minus negative 2, x minus 3. Okay? It looks like I got two negatives there, so let's clean those up. You don't need to write the positive 1. Okay? Positive 1 is positive 1. That's nothing special. So you just write it like this. That's the equation that represents this graph. Okay, does anybody have any questions? This is a little bit better. Actually, a lot better, because you can do more with it, which we saw last week, right? We can find, if we know, if we know what these two values are, okay, I can find the middle of them. It'll tell me the axis of symmetry. Okay? So it's a little bit more useful. I can find out more information from this equation, than this one, which is why we use it, which is why I show you factoring, so that we can switch this equation into this, so that I can answer more questions about the flight of something, or as we'll see today with word problems, okay? That's what we're going to do on the next question. Okay? We're going to factor these to find the zeros. We're just going to do a little bit more practice figuring out how to factor, first of all, with man method, and then identifying what the roots could be, and then we could produce a graph, right? We know what it would look like. Okay? It's a lot. This is, I'm not just showing you a math skill just because show you a math skill, right? Like, we can, by factoring, we can figure out a lot of stuff. Okay? We can produce these graphs very easily with the factoring, which is why we do it. Okay, does anybody have any questions before I go down here with what happened here? If you remember this, there's one thing you're going to kind of remember, it's this. If you know this, then you can just take whatever the two numbers are and you put them in where the blue highlighter is. Verbatim what the numbers are. If it's -2, you put in -2. If it's +3, you put in +3. If there's two negatives, clean it up. For those of you that do remember why I said, we're going to see this in a minute, you'll see why last week we're like, well, why is this the opposite sign? Why are these opposites? They're opposites because of this double negative thing going on in here. Okay? This is just the form. You have to follow this as like a rule, right? You have to follow this equation in green. That's a rule. Okay? If you follow it, you plug in the numbers where you know they come from. It's not that hard, right? Okay? So let's go down. Here's what we have to do here. We have to factor this thing. Okay? I guess my opening question is this opening or direction of opening? It's opening down because of the negative. All right, so I know my parabola is going to do something like this, right? It's frowning. It's not this. Okay. Okay, so here's what we need to do. Again, I don't necessarily know what my parabola looks like from this. Not my favorite form of a parabola. Okay. So what you can do, though, is you guys can figure out how to switch it into something that looks like this, because that's a little bit more useful. So how do we switch it? Well, we switch it using the factoring process. What type of factoring are we using? We see that there are 3 terms there, so we're going to try to apply our man method. Any 2 numbers that multiply to, or remember, sorry, we'll do this in a specific order. A, the addition, is always in the middle of the word man, so it goes right here, in the middle of the trinomial. So we need 2 numbers that multiply to -8 and add to -7, because the A always goes in the middle. And the M goes with the number on the end. And remember, you have to take the sign that's on there, right? And so we need 2 numbers that multiply to -8, add to -7. So now you're just going to start running through your numbers. You're like, okay, I need to make 2 numbers work that satisfy these 2 conditions here. Okay, that's our rule. Those are our rules. So you're going to go back to playing your game there, right? Where you're like, okay, 1 times 8 doesn't necessarily, it equals 8, right? But you need it to equal -8, which means one of them is going to have to be negative, right? Which one's negative? Okay, we got to figure that out. Well, if I make the 1 negative, that now multiplies to -8, so we're good. But we still have to check the second condition of, do these 2 numbers, -1 and 8, add to -7? So let's check it. -1 plus 8 equals +7. Okay, so that doesn't work. So let's go back to the drawing board here for a sec. What if I made the 8 negative instead? Well, 1 times -8 is still -8, which is great. But if I check it now, 1 plus -8, that equals -7. Now we've satisfied both conditions. Right? So we're good. Okay. So now, I told you guys, once we find what these 2 numbers are, the 2 numbers that work are going to be 1 and -8. That's not a point. Once we find these 2 numbers, we can take what our variable is, in this case, t, and I can rewrite the equation. T plus 1, that came from here, t minus 8 came from here. What are my 2 x-intercepts? Well, it looks like they always take the opposite sign. So x-intercept we'll call it x-intercept 1, is going to be when t equals -1, right? It's the opposite sign. So it's at -1, 0 is the first point, right? Because y, it's always x and y. The second x-intercept is always the opposite sign, 8, 0. You could now go plot these 2 points on your grid, say for instance, somewhere along here, right? If I were to sketch this, let me make one side bigger than the other. You could plot the point -1 and 0. Then you could plot the point 8 and 0. Okay, and what I'm doing here, this is like, if you guys can't print out summatives and things like that, or formatives, don't leave the graphs blank. At least try doing this, right? Like, this is okay. If you sketch this thing and you label your points and you tell me where everything is, I'm okay with that. Okay? Your next job, you're going to say, okay, well, I know this thing has to be opening down, so it has to do something like this, right? Okay, well, where's the vertex, right? That should be your next question. These are all things that we did last week, right? We're like trying to produce the graph given some ugly equation from up here. That's what we're trying to do here, right? We're given this ugly thing here. We don't know what that looks like. We could do it by using the table of values and coming up with your inputs and outputs, right? We could do that and then plot the points. We'd see something like this. But that takes a long time, and it opens, as we saw, ourselves to errors as we go along. Whereas instead of doing that tedious process, I can apply our factoring skills with our man method, right? I can find where the 2 x-intercepts are, find the middle of them, and then I know the vertex lies somewhere along there, right? And you can figure out where it is, and then you can produce your graph very nicely. And that's much better and faster than doing the XY input output. Okay, that I showed you when dealing with an equation that looks like this. We don't want to do that. Okay, very easy to make a sign error, get the wrong graph. Okay, do we have any questions? I actually think, to the extent at which we're doing the word problems with this stuff, I actually think it's not too bad. Okay, I think you guys will be okay. Okay, you're just gonna like put real world scenarios on these parabolas so that they might even lock it in for you a bit better, right? I don't know. Okay, so we're just gonna run through a couple of these. Okay, so here's somebody shooting a basketball. Okay, so when you shoot a basketball, I'm just gonna start identifying some terminology for you. I'm just gonna try and pick a color that I think is gonna stand out here, though. That's not bad. Thicken it up. Okay, so I'm just gonna draw. Let's say the ground is 0. Okay, obviously. So there's no height, right? And then up this axis here, I'm strategically drawing this axis. Okay, we're gonna have a y-axis and an x-axis. Okay, x is gonna be what we're gonna call horizontal distance. Okay, y is gonna be height. How high did the ball go? Okay. So what we're going to try and do is contextualize. This ball is going to go up Why does it stop there? Like for instance, when I throw a basketball up in the air, why does it not do this? Actually, it wouldn't even be curved. It would just keep going in and going. Why does it do that? Why does it choose to curve? It chooses to curve here because of gravity. Gravity's forcing it to come back down, right? But gravity's always acting on it in the same way, right? If it's acting on it in the same way, then there better be some symmetry about when it decides to start coming back down, which we called an axis of symmetry. Okay, so I better see some form of symmetry. I don't know if it's going in the hoop. I probably just overambitious. Okay, I better see some symmetry between both halves of the path of this basketball, right? Because gravity's forcing it to be the same on both sides. Okay, there was no gravity, it would just take off. There'd be nothing impeding it from continually going up. Okay, do you have any questions? This would just be one application. Okay, there's lots of these. We're going to scroll down here and see like how the path of this basketball has changed with time. Okay, or horizontal distance. They may have even labeled it time. Okay, so you can see here, if I bring my grid back down here, the ground's still the ground, right? Well, the ball went up. If I trace the path of this thing, went up, slowed down, and then it turned around and started coming back down until it bounced off the ground. Okay? It looks like somewhere in the middle I have what we called an axis of symmetry. All right, well, if I asked you what is the maximum height the ball reached after being shot, you could say, okay, well, I know where the maximum height is. It's right here. Which we called a vertex. All right, well, that tells me the maximum height. What if I asked you from what height was the ball shot at? Well, where is that? That's over here. That's where the ball got shot from. Well, what does that look like? That looks like a Y-intercept. All right, well, what if I asked you, where did the ball hit the ground? Well, that looks like over here, which we called an X-intercept. Okay, so you can start seeing how all the stuff we talked about properties of quadratics, right, can be applied to a real life situation. Okay, and this goes far beyond. We're going to do lots of questions today about, balls thrown, but this also applies to like revenue and costs. Okay, there's lots of financial applications of this as well, right? Especially when we're talking about there's like a maximum amount of money that can be made under certain conditions, right? How much do things cost relative to how much do you sell them for? Under those, there's a balance in those situations such that you're going to reach a maximum amount of money that you can make. Okay? Does anybody have any questions? A lot of what we talk about comes out of, can we talk about maximums or optimal values, vertex, okay? Can we find that point using the tools that I've given you, okay? Remember, the tools I've given you is like exactly what we did up here. Factoring with man method, or finding the equation given a graph, okay? Any questions? So this is just putting a graph on there, okay? Like an actual grid. You can see, okay, well, it looks like the ball came down 5.5 meters away. What was its maximum height? Its maximum height looked like, if I drew a horizontal line from here to there, I don't know, pretty close to 7.5. Maybe not the best color to be using, but right. So it maybe reached the maximum height of 7.5 meters, we'll call it. Okay. How long did it take to reach its maximum height? That could be another question. How long did it take? Well, we go find the vertex and we bring it down. Well, it looks like, oh, it took 2.5, or sorry, it could be time. It said 2.5 meters it took, right, to reach its maximum height. If this was time down here on this axis, then we could say, okay, it took 5.5 seconds to hit the ground. How long did it take to reach its maximum height? 2.5 seconds. Okay, these are all things that we can start answering using all of our properties. Okay. Okay. Okay, so we're going to see here a tennis ball was 2 feet off the ground, 2 feet off the ground when a tennis player hit it, so that the ball traveled up in the air before coming back to the ground. The height of the tennis ball is described by the graph shown. Numbers along the x-axis represent time. Okay, so where the ball is, any particular time across the point of travel, right? After the ball was hit, the numbers along the y-axis represent the height in feet of the ball at time x. Okay, so we could answer all sorts of different things here, right? This is just reiterating what we finished talking about. It's just a different scenario now, right? If you guys have ever watched a tennis ball get hit, how long does it typically take for it to come back down to the ground? Not that long, okay? So it might look like, okay, it looks like, I don't know, this is kind of a guess. If it gets hit here, right? This question is saying it gets hit 2 feet off the ground, okay? And then I'd probably say, I don't know, it takes 1.1 seconds to come back down to the ground. What was the maximum height that the ball reached? The ball would have reached 6 feet in the air. How long did it take to reach its maximum height? Half a second. Okay. Any questions? These are all sorts of things that I can ask you, right? Okay. I don't know where the graph is. Must have disappeared. I don't know what happened. So we'll have to skip that question because we don't have a graph to go off of. Okay, but we can go down to the next one. Okay. Okay, so here's a little bit more like formalized, the sorts of things that I'm looking for. Okay. Okay, so it looks like a ball got kicked, for instance, right, from the ground. Okay, these are the sorts of things that we're looking for with these questions. How many seconds will it take for the ball to be at its highest? Okay, well, it takes, if I'm looking, okay, the ball gets kicked. Here, I'll use a different color. I'll use a highlighter. Ball gets kicked. It goes up, 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 up. Starts slowing down. Oh, reaches its maximum height. How long did that take? Looks like 2.5 seconds it took. Okay. We could, I'm going to like you guys to label things like max height. Or another word for that, I'm going to change my pen size too. Another word for that is the vertex. Okay, if you guys remember, we talked about how the vertex and the axis of symmetry and direction of opening, how these things are all related. If I asked you what the optimal value was, right? Right? That's asking about what was the maximum height of the ball, right? And then you would put into words, you'd say, okay, well, it reaches a maximum height of, well, how high did it reach? Looks like 19 meters. Okay, it reached a maximum height of 19 meters. How long did it take to reach that maximum height? After 2.5 seconds. Okay, this actually isn't much different than, if you guys remember from the first summative there, we put the snowfall on a graph and I asked you guys to interpolate versus extrapolate. It's not really the same thing, but we're reading points or points of interest off of a graph, right? And you guys were able to look at that kind of line of best fit, and we said we could take a guess as to what the how much snow fell in the first 5 hours. That's fine. The difference here between is that this actually represents the physical motion of the object. Okay, so this is an exact graph. We don't need to take any guesses, so there is no interpolation versus extrapolation, right? Because this is an exact graph of the object's motion. But the transferable skill there is, if we look at how high is the ball 3 seconds into the throw, we can go find 3 seconds, right? You say, okay, well, where's 3 seconds? 3 seconds is right here. Okay, well, if 3 seconds is right there, then I'm going to read up and see where the ball is at 3 seconds. Where is it? Oh, it's right here at this point conveniently. What's the height of that point? 18. Okay. All right, well, let's look at the next one. How many seconds until the ball hits the ground? Well, it looks like it gets kicked here. It goes all the way up. And here's the cool thing about finding this axis of symmetry is, let's just suppose that I didn't give you this half of the graph. I only gave you half of the object's motion. I've told you that if the ball reaches the maximum height, and I've given you half of the object's motion, then you should, in theory, be able to say, okay, well, it took 2.5 seconds for the ball to reach its maximum height, right? So if I say, okay, well, how many seconds until the ball hits the ground? Well, if it took 2.5 seconds to get to its maximum height, which is halfway, then it better take another 2.5 seconds for it to hit the ground. right? So you could say, okay, it would be 2.5 times 2, which would equal 5 seconds. Does this make sense? Yeah, it does, because it's right here at 5 seconds. That's when it hits the ground again, 5 seconds later. Okay? And the last question here is, when the ball hits the ground, what's the y value? Or its height? Well, when it hits the ground, it's at 0. Okay, it has no height now because it's hit the ground. Is there any questions? Something interesting that we could do, if I just draw your, we don't need to worry about this because we already answered this. If I draw your attention to this equation here, I'm just going to bring back a skill here. The cool thing is like we can answer these questions with graphically. We can also answer them algebraically, which I gave you the skills, right? So if I rewrite the equation here, something interesting happens if I try and apply or factor using GCF, or greatest common factor. All right, well, let's identify what the GCF is. Remember, I'm always trying to deal with, when I'm looking at a polynomial, there are going to be multiple terms in a polynomial, right? And a term has numbers and also variables. In this particular question, I only see one variable, it's x, right? So your question is, when you're trying to build your greatest common factor, is what number can I take, or the biggest number that I can take out of both terms, right? So what's the biggest number that I could take out of both number 1 and number 2? Looks like I can take -3 out, right? Because it looks like I can divide both numbers, both 3, or sorry, -3 and +15. I can divide them both by -3. Okay. All right, so that's good. We've built the first piece of our greatest common factor. The second one is, you ask yourself, what's the biggest number of x's that I can take out of both terms? Well, it looks like number 1 has 2 x's, but number 2 only has 1. So it looks like I can only take 1 x out, right? So if you can only take 1 x out, now you've built your greatest common factor. Okay? So if you were to factor this using your greatest common factor, that simply means write or tell me what's left after you remove that greatest common factor. So you've identified what the greatest common factor is. It's -3x. So you remove it, and you're left with something on the inside. The something on the inside is what happens when you divide both of these things by your greatest common factor. All right, well, let's start doing the math then. I can divide numbers by numbers. -3 divided by -3. Well, that's just 1. All right, let's do the next piece here. It looks like this x here is going to cancel with one of these x's in the top, right? So I'm left with just an x, 1x. And then you can do the math on the other number. Well, it's 15 divided by -3. That's -5. And then it looks like, okay, one of this x down here can cancel with this x up here. And that's it. You're left. You're done. So if I rewrote this, you don't need to write it with the 1. Okay. I said something the other day that if I was to try and figure out the x-intercepts from this, like what are my x-intercepts? Well, I told you they always kind of took the opposite sign, right? Remember what this is. This is in factored form now. It's in factored form because I factored. Okay. It's when it's in factored form that we saw earlier, we were able to find what the x-intercepts are. Okay, well, I know what one of them is right off the top because I told you guys, as soon as you write it in this form, you can see what one of the x-intercepts are. It always takes the opposite sign that's sitting there. Well, one of them is at x equals 5, right? So your x-intercept for this one is 5 and 0. Okay, this one's a little bit, it's harder conceptually, but I suppose you could write this as well. I've never done this before, thought of it like this, but I suppose I could write my equation like this too. I'm running out of space. Okay, we saw where this came from. Okay. What is this number with an opposite sign on it? Right? Everybody see what I did? I just added 0. I haven't changed anything. Just added a 0. What's the opposite sign of positive 0? 0. Negative 0. It's still 0. So your second answer is 0, or the point 0, 0. Here are your two x-intercepts. I'll use a different color just to highlight them. Okay. So what I've done here is I've illustrated to you, or tried to connect you to the work that we were doing last week and how that relates to the graph. Where are my two x-intercepts? In theory, they should be at 5 and 0 and 0, 0. Is that not where those 2 points are? It is. Okay, so my point is, this is going to kind of wrap this up here, and we'll finish. If you guys come back at 1 o'clock, we'll do this last question in 10 minutes, and then you guys can work on your assignment. Okay, you should have all the tools to do that thing. But just before you go, I want to illustrate to you, in the event that I don't provide you with what the graph looks like. Right, so let's say this was not here, but I did give you this. You could apply the processes that I've shown you last week, figure out what it looks like in factored form, right? And then tell me what the two x-intercepts are. Once you have those x-intercepts, you can find the middle, the axis of symmetry, then you can find the vertex. Then you can answer all of these questions listed right here. Okay? We're able to answer all of those questions because we've practiced factoring. Okay? So I don't need to hand you the graph. Okay? Does anybody have any questions? Okay? It's not... and just looking at some of your quizzes briefly, like it didn't really seem like identifying the key features was that bad. Okay, that's all this is. It's just now we're putting key features on word problem scenarios, right? The hard part is going to be applying our factoring skills to switch things into factored form so that I can answer some questions. Okay, that's going to be the hard part. Okay, and that's a hard part for everybody. Okay, it's going to take some time. Okay, so hopefully, like, we'll come back to this before the end of the course too, right? But for today, you guys have a chance to, I don't know, I'll make that assignment due on Wednesday. You guys can have a go at it. I'll post it now. Okay, I'll mark your quizzes so you guys know what you did right and wrong. Okay, and then you can have a go at doing that assignment. Okay, does anybody have any questions? I'll stop the video there. I'll post this so you guys have it.